Hello everyone, this is Chandrashekhar welcoming you all to the Daily Dose series for civil and mechanical engineers. The objective of this series is to bring the most important or the most frequently asked questions or the concept for your benefit. So in today's session, I have picked one important question or we will discuss the concept with the question itself. So the topic will be heat transfer, the subject will be heat transfer, and the topic will be unsteady state conduction, or more specifically, it will be from the lump system analysis. I hope you guys are comfortable with the lump system analysis. All right. So we will solve one question, and keep your pen, notebook and calculator. Try to solve on your own as well, and try to see whether your approach is same as mine. So this is my introduction for those who are meeting me for the very first time. Let us jump to the question without any wastage of time. All right, the question is, can we determine the time of death of a person by using the concept of unsteady state conduction? Have you ever seen or heard about the concept of determining or predicting the death of a person by using the lump system analysis? Let us try to make the model for the given situation. Let us start. The temperature of a healthy person is around 37 degrees Celsius, or the temperature of the person when he dies. We can call it as initial temperature. Let me call it as initial temperature. All right, that is the initial temperature. Now, when the dead body is found, it is found at 5 p.m. and the temperature has dropped down to 25 degrees Celsius. It is the temperature at any instant when the body is found, that is T. And the room temperature is around 20 degrees Celsius, that is T infinity, flue temperature. And the convective heat transfer coefficient is 8 watt per meter square Kelvin. These are the parameters, and the human body can be modeled as a cylinder of dimension. We can model the human body as a cylinder of length around 1.7 meter, around 5 feet or more than 5.5 feet, and the diameter is around 30 centimeter. It can be treated as a cylinder of these dimension. And as you all know, the human body is mostly water, 72% is water. So we will use, for the human body, we will be going to use the water properties. At which temperature? At the average temperature. We can call the average temperature as 37 plus 25 by 2. So that is 31 degrees Celsius. So the thermal conductivity, density and specific heat of water at 31 degrees Celsius are these. We will use these parameters for human body. So we can assume the system to be a lump system. Conductive thermal resistance is very, very less compared to our convection. There is no change in the temperature of the human body with space. The whole human body is at the same temperature at any particular instant. So we can use the lump system analysis. So we can use the lumped system analysis. And what is the formula for applying the lump system analysis? So we can say theta upon theta I, that is equal to e to the power minus HAS by rho CV into tau, or we can say tau is equal to, or we can write it as HA by rho CV into tau is equal to minus ln of theta by theta I. Theta is equal to T minus T infinity and theta is equal to Ti minus T infinity. These are the value. And volume per unit surface area, volume is pi by 4 d square into L, and surface area is equal to pi dl. So volume per unit surface area is equal to d by 4. We will use it at d by 4. So we can find out the value of tau. Tau is equal to rho into C into volume per unit surface area, that is d by 4 into h, isn't it? Rho C into d by 4 into h into ln of theta I, that is Ti minus T infinity upon T minus T infinity. That will give you the time taken to reduce the temperature of the human body from 37 to 25. Put the value. Density is 996. Specific heat is 4178. Diameter is 30 centimeter, that is 0.3 upon 4 into h is 8 into ln of Ti is 37, T infinity is 20. So it will be 17. Divided by T is 25 and T infinity is 20, that is 5. So if you simplify this, then time will be around 47742. 47742 seconds. What does that mean? That this is the time taken by the body to reduce the temperature from 37 degrees Celsius to 25 degrees Celsius, or in R it is around 13.26 hours. It means the person must have died 30 hours earlier to the time when the body was found. So if the person have the body is found at 5 p.m. in the evening, so the person must have died, or let me use another slide. So the person must have died around 13 hours before. So it is around 4 a.m. in the morning. If you have liked this concept, please do subscribe our BYJU'S channel and stay in touch for more such beautiful concepts and the questions. So this is all about this session. I will bring more such session. Thank you guys. Thank you very much. Take care.